Hello, everyone. You are welcome to today's lesson. And today's lesson is going to be a short one. Our task basically is to look at the solution to the assignment that was given in lesson 5, okay, of rational functions and partial fractions. Okay, and just as you have on your screen, okay, this is the assignment. Okay, so quickly let me go and walk you through the solution. All right, and you should know that you are going to mark yourselves, and anytime you mark, it means you are supposed to submit your marked work, okay, as well. And you must always indicate your final score over the total score. Okay, written on top of your first page boldly. It should be very clear, okay, and visible. Okay, so now quickly let me take you through, okay, the solution. All right, and as I walk you through, I will address most of the concerns, if not all, especially the major ones. Okay, however, if after that we have any outstanding concerns, particular concerns that I told you to remind me to address, if not addressed, okay, in class, please don't hesitate to do so. So, as usual, okay, questions we read, underline salient part, if any. Okay, express. Okay, this in partial fractions. So usually rational functions, we are asked to express in partial fractions. So this is the usual way. No special, okay, anything salient to underline. So at this point, you go and write solution. Okay, then you write a question number, major question number. You extract what you are given. You can choose not to write the given, but this one, okay, it's not a matter of choice. You have to. Okay, so you extract this, then after that, okay, first question you ask yourself, proper or improper? Degree of the numerator is 3. That of the denominator will be 2. This factor is 1. This factor has a degree of 1 as well. So if you add, you are going to get degree of 2. So making the rational function there improper. And once it's improper, we know we cannot straight away go and write the identity and therefore find what's the partial fraction representation of that. So this means that we have to, first of all, write this improper fraction as a sum of a polynomial, which we usually say will be your quotient, then plus your rational function, proper rational function, which will come from your remainder over what? The divisor. So once we have this in mind, we know we are going to go through the long division before we can express this in that form. Polynomial plus proper rational function, quotient plus remainder over divisor. So what do we do? Okay, we know in performing long division, okay, our the divisor dividend, if possible, we have to write it in the standard form and all terms written out completely. Okay, so now what do? We know numerator, which is the dividend, okay, is given, it's written in the standard form. Okay, then the denominator, obviously, you know, it's not in the standard form. So we need to remove the brackets. So this calls for the expansion, which gave us what? 2s squared plus what? X, or which gives us 2s squared plus s that we have here. So at this point, you come and perform your long division. Okay, so that's where you have to be very careful because some of the values that you are going to deal with will not be that pretty. Okay, it will not be the usual, okay, whole numbers or integer values that we get. Okay, so now, okay, the divisor is written in the standard form, but not completely. I don't need it to be complete. So the zero that you introduce will not be. So the standard form and the complete form, usually, okay, you are, especially the complete, okay, you are supposed to consider that or make sure that your numerator, which is the dividend, satisfies these two. As for your divisor, which is the denominator, okay, what is important is you should satisfy the standard form. If it's not written out completely, you shouldn't be worried. So take notes. Another vital information. Originally, I told you make sure each of them, okay, completely written out and also in the standard form. Okay, but now we are mature, so I can tell you that the divisor standard form is very critical. As for complete, you can choose not to. Okay, so now, just as you have here, I didn't introduce my constant term because this is the divisor and you can choose not to meet that. So you go through your long division. So I'll quickly walk you through because you are expert. So we are going to get s cubed, okay, over 2s squared. And you know this is what we are going to get. So s cubed over 2, okay, x squared. So we know this s squared will take care of 2 of the x's in the numerator. So you cancel this, leaving you with x over 2, which is the same as 1 over 2x. So that's what I've written here as my quotient. Okay, so at this point, you come and multiply this one by all the terms here. So if you multiply, we are going to get this. This time, this will give you, okay, s cubed. This time, this will give us what we have here. Then after that, you come and subtract. If you subtract, always this will go. Now, this is going to give you 0s squared minus 1 over 2s squared. And that will give us minus half s squared. Okay. Then after that, you bring these two terms down. So I have done exactly that. Then, because we realize that what you have here, your new dividend, the degree is not, okay, less than this. That of the divisor, you can't stop. This is only a new dividend. You can't call it a remainder. Okay, so you kickstart your process again. So you now come and do minus 1 over 2s squared divided by s squared. So this is what you have. If you can't do it mentally, always there will be room here for your rough work. That's why you've pushed your work to this side. Okay, so that will give you minus 1 over 2x squared, okay, divided by, okay, 2x squared. So which in effect will give you minus 1 over 2x squared, then times 1 over 2x squared. So this s squared will cancel this s squared. Okay, then you are going to get minus 1 times 1, which will give you 1, then 2 times 2, so sorry, which will give you minus 1, then 2 times 2, which will give you, okay, 4. So you are going to get what? Minus 1 over 4, so which is written here. So again, you come and multiply each of the terms here by your new quotient, which is the minus 1 over 4. So if you do that, we are going to get exactly what we have here. So at this point, again, you come and subtract. And I've told you, don't forget to indicate this bracket as well as your subtraction. Okay, so if you subtract, always the first will go as usual. Then this will give you 10x minus 1 over 4x. So that will give you 10x plus 1 over 4x. Okay, which will give us what? 10 whole number 1 over 4. Because this fraction here is proper. Okay, and a whole number. Always, it will be your whole number, then you attach your proper. So 10 whole number 1 over 4, which changes to, in terms of what? Its improper fraction, it will be 41 over 4. So that's what you write. Don't write the mixed fraction or mixed number version. So that gives us 41 over 4x. Then you bring the 14 down. So at this point, degree of the new dividend is less than that of the divisor. So this means this becomes our remainder. We stop here. But you should know that, okay, we were writing this, okay, as a sum of what? The quotient, which is what we have here. So I am going to write that, okay, I didn't bring the 4 here. So take note. However, please take note. Okay, so it will be equal to your quotient. Your quotient is more than a term. And remember when we were doing the polynomial function, I told you, if it's more than a term, you put it in brackets. Even, okay, for you to play it safe, I told you that always put your quotient in what brackets. Okay, whether it is monomial or what have you. Only that if you are matured, you know that if it's monomial, the brackets will not be necessary. Okay, so you bring to bear your maturity. But here it's not a monomial, binomial. Put it in brackets. Other than that, the meaning changes. Then plus your remainder. What's our remainder? Our remainder is this. Okay, over your divisor. And what is your divisor? Your divisor is this. And you can see that once again, I didn't go for the expanded version of the divisor because I knew, okay, I will come and take this fraction here, which is the improper fraction coming from your remainder over the divisor, and write the identity and resolve. So that's why I went for its factorized form, the one that I used to expand. So I substitute that straight away or go for that. Okay, so on that note, we know we come and take the proper and what and find the identity and rationalize, sort of, or rationalize, meaning you go through the identity. So taking, remember, you have to come and write taking. So we take this, taking this, okay, which is what we have here. okay, then what do? You are writing this, okay, as a partial fraction. So we have to go through the identity. Okay, proper, obviously, yes. Numerator degree 1, denominator degree 2. And I've told you, once you do the writing, this will always be proper. So you don't even have to ask that question. Okay, unless maybe you want to play it safe. So for consistency's sake, you do want to ask yourself this question, that's fine. Otherwise, this will always be proper. So maturity will let you know that this is proper. So you don't ask yourself that question. Go straight away to the denominator. The denominator factors, linear factors, okay, none of them is factorable. So it means I'm going to get, once I have two linear, okay, non-factorable factors, I'll get two fractions. The first fraction, the denominator will be x. Okay, it's linear. Its numerator will be a constant. The second fraction, the denominator is 2x plus 1. It's linear. Okay, sorry, plus 1. Forgive me. This is supposed to be plus 1. Okay, so you take note of that. So at this point, what do we do? The numerator will also be a constant. Okay, and don't forget your identity sign. I will come to the penalties. Okay, maybe I can even say it so that, okay, if it is equal to, please write, okay, minus 1. If you use equal to without the identity, because I've said it, I've told you times, okay, without number. That's where you introduce your letters. That's where your identity sign should come. Then after that, okay, or equal to all the way. So the next step is to write this. We've written the identity, so now we are going to, okay, get the values of the a and b. So we said we have to write this out as single fraction, which I have, and I think this one you should all appreciate. This x will go into your LCM here, 2s plus 1, then times the a. But 2s plus 1 should strictly be in bracket because it's a binomial. Then this will go into the denominator, your LCM here, x times. So x times b will give you bx. So that gives us what we have. At this point, the denominators are the same, so you just equate the numerators. So the numerator that you have here, you equate it to what you have here. And, okay, like I said, will always go for, at this point, you are at liberty to use the method of comparing coefficients or, okay, the cover-up method, the elimination method. But I will go for, like I say, I am expert. I always want to go for the elimination or the cover-up method. So on that note, because again, your factors are linear, it is always convenient to go for the elimination or the cover-up method. However, if you want to use the other one, you can. It's your time. Okay, in fact, it's our time, so I'm advising you to use the time wisely, basically. So now, what do we do? Okay, you check, at the normal circumstance, the two critical values that you can substitute based on the linear factors will be, okay, if you take the first linear factor, okay, the first linear factor here is x. So it will be set it to 0. So x is equal to 0. So one substitution for x will be x is equal to 0. The other possible solution, or sorry, substitution will come from 2x plus 1. So it will be 2x plus 1 is equal to 0. Then that will give you, if you solve, x will be equal to, this is your rough ratio, so it shouldn't be that detailed. If you can do some of them mentally, you do so. So minus 1 over 2. So these will be the two critical substitution based on the factors that we can go for. But because, like I said, I'm an expert, I'll bring my expertise to bear and give you a certain advice. I usually don't want to substitute fraction if possible, and here it will be possible. So I will guide you how to do that very soon. So at this point, okay, I will go for s is equal to 0. Okay, the order in which you substitute doesn't really matter. So I'll go for that one first. So if x is equal to 0, wherever I see x here in this, okay, relation to be 0. So I substitute 0, okay, there. And that gives me, this side will go, it will be 0. Okay, so I will get 14 on this side. Okay, it's equal to, this will give you 2 times 0, which is what? 0 plus 1. So I will get 1 times a. So that will give me a. This will go, b times 0 will give you, okay, 0. So you don't write it. So that gives you your value for a. So you know the value for a. You are left with, okay, that of what? Of the b. So we are going to look for the b. Okay, so if you want to go for the b, then it means we have to cover this. If you cover this, okay, this must be 0. So that will give us s is equal to minus 1 over 2. If you like, you can substitute. But like I said, here the substitution is not that pretty. I always want to avoid fraction. Apart from the fact that it is a fraction, it's also negative. And I've told you, I don't like negative as well. So the 2 will put me off. So what do I do? Now look at what I'm going to do. Okay, I'm going to carry out a substitution in such a way that so it means I'm going to more or less pick a liberty value, another liberty value. Okay, that will be convenient, okay, to avoid fraction. So if you look at what I have here, please listen at this point carefully. This is the first time I'm introducing you to this. Okay, all right. So if you look at this carefully, okay, my term that contains a fraction is this. So how will this fraction go? If this fraction will go, then it means my x here should be 4. I don't know if you get my point. So that it will cancel. And in fact, I won't get any fraction. You get my point? My professors, are you following?
Yes.
Okay, so like I can ordinarily you should have gone for x is equal to minus 1 over 2. But I said, okay, here, if you substitute minus 1 over 2, you can see that you get a fraction here, you equally get a fraction here, and you'll be, apart from the fact that you write more, you use more space because every fraction will take 2 lines, especially those of us who use 2 lines for fractions. Okay, so now, okay, so I will go for s is equal to 4 because I want this fraction to go. So instead of minus 1 over 2 for x, I will go for x is equal to 4. So that informed the decision for what you have here. So if x is equal to 4, it means wherever I see x here, I have to substitute 4. So that will give me 41 on 4x plus 14 is equal to a into 2 into 4 plus 1 plus b into what? Into 4. And that's exactly what I have here. Okay, so I know this 4 will cancel. So in effect, I'm going to get 41 plus 14, which will give me 55. And this will give me 2 times 4, which is 8, plus 1, 9, times a, so 9a. Then b times 4 will give me 4b. Okay, so at this point, you know the value of a, so you go and substitute. Okay, the other one, if you had substituted, okay, the a would, I'm talking about the s equal to minus 1 over 2. Okay, if you have substituted, the a will vanish straight away. So you get your equation in b and you solve for b, only that it will involve a fraction. That's all. Okay, but with this approach, after substituting your s equal to 4, okay, and simplifying, okay, none of the letters will go. So you have to, because you went for what we call a liberty value. Okay, not the values coming from the factors. So you should know this by experience. So as you continue, a you know is 14, you substitute. If you substitute, you are going to get 55 is equal to 126 plus 4b. You are looking for b, so you isolate the b. I wrote the 4b first. That doesn't mean I'm here. That doesn't mean I moved. Okay, in my mind, I have maintained it here. So that will be equal to, is this that I will move. So that will give me 55 minus 126, and that will give us minus 71. You write it again before you divide. And I believe you are taking note of the marks there as well. So if you write it again and you divide, b will be equal to minus 71 on 4. Okay, so at this point, what do I do? Okay, I know the values of a and b, and therefore my quotient. So okay, I can quickly come and draw my conclusion. So therefore, whatever that I was asked to resolve or express into partial fraction will be equal to, remember, it will be the quotient plus the resolution of what you have there. So remember, so the quotient, which is what we have here, plus the resolution of the fraction that you just did. So the fraction, the a, let's go back and see the form. So we said it will be a over x. Fortunately for us, even if a was negative, you are not bothered because your first term is the quotient, which is this. Okay, so a gave us what? What do you call it? Okay, so that gave us the 14. So 14 over x. Then the b should have been plus. When you are matured, you can do whatever I've done here. So it should have been plus, okay, minus your b is what? 71 over 4. Okay, all over your x, sorry, 2x plus 1. Okay, but you know, per experience, this negative will make this one, the positive here override it. So that will make it negative. Then I said you bring this 4 down, keep your numerator. So it will be 71 over 4 down. Then you keep your denominator 2x plus 1. So multiplying that, and that's what I have here. Is the explanation okay, my professors? So
Yes, please.
if you are able to do this question, and some of you didn't attempt, okay, at all. And please, you see, like I said, every little marks counts. So even if you cannot, okay, do anything, I know at least, if for nothing at all, wouldn't you be able to extract? You will be able to extract, is that not it? So even if you save this half mark based on the extraction, protect it. So if you don't want to submit, okay, the solution to one, at least I know you are not empty. You should be able to write something. And like I said, at least you should be able to extract. So if your extraction, okay, were around some marks, then you protect your marks rather than leaving it empty, not writing anything at all. I don't know whether you get my point. So it means everybody at all of you, you start, okay, with a particular score, which will be the score, okay, from the extraction. You should all be able to extract because the extraction is just copy and paste. It doesn't require any input from you. Then you, at least I know these 2 marks, you should be able to get it. You know, proper, improper. So once it's improper, then we need to go and do the long division. The long division, I have to make sure my divisor, my dividends satisfies a particular condition. So I do that. So if here you can't carry on, that's okay. At least you've protected 1.5 marks. That's okay. That can push you somewhere rather than leaving it empty. Okay, not writing anything at all. I don't know if you get my point. Is my point well made?
Yes, please.
Okay,
Yes,
so,
yes,
all
please.
right, take note of that. So at this point, I think that will be it for the solution to this. So if you are, okay, the total marks for the question one is 15. So take notes. Okay, all right. Okay, so now at this point, we come to question 2. Question 2, what are we supposed to do? Okay, if this is identical to this, find the value of A, okay, B as a point. So here you need to underline this because the way you conclude will be different from the usual. Okay, so then this is where your conclusion, most of you get it wrong. I mean, I should say got it wrong. Okay, so if you don't take care, you will get it wrong if you don't underline. Okay, so now what do we have? You extract, which we have extracted. Okay, then after that, so this one, you shouldn't lose it. We know the identity has been written for you. So the next step is to, okay, right, take it as a single fraction. And as for here, we should all be able to proceed. 2 linear factors. So what do we do? Okay, we now equate the numerators. Once you have 2 linear factors with 2 unknowns, it means you can go for use the linear factors to get your critical substitutions. So x will be equal to -3, one of them. X will be equal to -6, the other substitution. So here they are pretty values, no fractions. So go for them. Okay, unlike the other one, that one was a fraction, then I said, then let's go and look for a convenient substitution. Okay, so now if s equal to -3, substitute, okay, you simplify, then you end up getting what we have here. A is equal to -2. Okay, then you come to, if s is equal to -6, okay, comma, I've told you don't let this take one line. So you are going to get your direct substitution, you simplify, you get b to be equal to 4. However, you cannot go and conclude that therefore this is equal to, then you substitute the value of A and B. Be very critical. The nature of the question will tell you how best your conclusion must be drawn. So here the question is asking us to find AB in terms of point, the value of AB. So find the A value, the B, but put it in the point form. So in this case, I will draw my conclusion. Therefore, AB will be equal to, what is my A? -2, comma, what is my B? 4. Okay, so this should be your conclusion. Or somebody can write, therefore, okay, -2, 4. This is what AB in its value form and point form. So if you conclude, therefore, A is equal to -2 and B is equal to 4, wrong conclusion. Please take note. And I've told you, don't write. If the question asks you, I don't know why. If the question asks you, let it be the last time I will tell you this. If the question asks you to find the value of something, just whatever you are asked, maybe the value of A or values of A, just write A is equal to and state this value. Don't come and write, therefore, the value of this. Don't write that. Okay, if you write A is equal to 2, this is basically telling you mathematically that the value of A is 2. So don't go and write, therefore, the value of A is 2. or someone even wrote, therefore, okay, A is equal to. Instead of using the symbol for equal to, you write is equal to in words. When? Then it means all your equal to is here. You are supposed to write is equal to is equal to. So you are working against time. Learn to use, okay, our time wisely, judiciously, please. Okay, so I hope my advice is well taken. So now, okay, the total for the B will be 10 marks. So take note of that. Okay, as well. And don't give yourself marks that you don't merit. Okay. And here, it shouldn't be the identity. It should be equal to, take note. Identity formed for you. So after that, okay, equal to. All right. Then the last question, question number 3. Okay. So with this one, you are asked to find the value of M. Okay. So when you get your M, you are done. Okay, so again, the identity has been read. So solution, and please take note. Every major question, I think I'm repeating this because your test is around the corner and some of you did the wrong thing in the first test. Okay, take note. Every major question is a major question that you start with solution. So if this was maybe question 1, then I wrote A, B, C, then I would have written solution once because solution goes for a major question. So I'll write, so you don't write solution for every minor question, but you write solution for every major question. You get my point. My professors, are you with me? Because at the normal circumstance, you know, every major question should be on a fresh page, on a new page, every major question. All right. So now I guess my advice well noted. So solution, your third question, given, you extract. Okay, again, you know what's do you have? You have the identity. Okay, so single fraction, you are going to look for the value, okay, of M. So what do you do? Okay, equate the numerators because the denominators are the same. And take note, because here the factors are given, it means what you have here, the denominator, a quadratic denominator here, if you factorize, this is what you get. So go and check the factorization. No, it's not necessary. Okay, so they've given you the factors that, okay, this will result in. So straight away work with it. So this should tell you that if you factorize this, okay, you are going to get what you have here. If you like expand, you see. So now you just equate the numerators. Okay, then what do? You are looking for M. So expand this side, combine like terms, and that's what I did. So 6x plus M is equal to, I expanded this side, combine like terms, and that's what I have here. So here, indirectly, it's like I'm using the method of comparing coefficients. Okay, if you don't, someone can choose to just solve for x here. You should know that the M here is 6x plus M is equal to this. So this will cancel and you get M is equal to, or if you want to make M the subject, you can move the M to this, the 6x to this side so that you get M is equal to 6x minus 22. Okay, then minus 6x. The 6x will go, you'll be left with minus 22. That's, okay, another way. But I decided to use the method of comparing coefficients. So here I have 6x plus M is equal to 6x minus 2x. So if I compare coefficients, okay, obviously 6 is equal to 6. So I won't write, okay, 6 is equal to 6. It doesn't make mathematical sense. Okay, then I come to my constant. M will be equal to minus 12, and I was asked to, minus 22, forgive me. I was asked to find the M. So I draw my conclusion with the M. So therefore, M is equal to minus 22. So don't write, therefore, the value of M is no. Therefore, M is equal to, state its value. You are done. Okay, so this will equally give you 5 marks. So in all, we have a total of 30 marks. My professors, are you there? Hello, my professors, are you there? Okay, so any questions? Is the explanation okay? Were you able to follow through from the beginning to the end? Especially those who started with us. Okay, so if you are done with a solution, okay, so this becomes, so at this point, I think I can end, okay, this session. Okay, so thank you very much once again. God bless us all.